Like and subscribe, you dirty peasant.
Today I wanted to do a little rant about Delta Lake. I want to talk about why I think more people should use it. I want to complain about people that don't understand it or think that maybe Postgres or MySQL should work fine. I think there might be some confusion around what Delta Lake and other things like Apache Iceberg are used for. Lakehouse architecture. I know some people might think it's marketing buzz, and there is a lot of marketing buzz, but I still think that technologies like Delta Lake have a huge impact on current data engineering architectures and scaling data systems. And I'm just going to talk about that today at a high level conceptually. Like, if you're someone who hasn't really worked with Delta Lake before, maybe hasn't worked with Spark too much or that big data, you might hear these words a lot, hear Delta Lake, hear about Lakehouse, and just kind of like not maybe understand it totally or what is the big deal. I think it is a big deal, and I'm going to talk about why. First, at a high level, we'll talk about classic data storage, right? Most data engineers are used to Postgres, MySQL, databases, relational databases. That's how SQL Server, Oracle, for the last 20 years, that's what everybody's been using. Those were used for both OLTP workloads and OLAP, so like analytic workloads and transactional workloads. There's always going to be transactional workloads on relational databases like Postgres, MySQL. They always have their, their high response time, not high response time, low response times, right? Very quick, fast. They meet a need, right? Built into a lot of applications. And somewhere along 20 years ago, right, businesses started realizing they needed data warehouses. They needed to be able to run analytical workloads, do crunching of data across, big data sets, and we use those same tools. That's what we had, right? We had the relational database. So that's where different data models came in. Some of the books got popular. Data Warehouse Toolkit became really popular, right? It's a way of modeling your data, and those, really, at that time, it was relational databases, right? A data model and a relational database that can help you crunch large amounts of data. But as time went by, things got slow, right? You can run Postgres, MySQL clusters, right? You can run SQL Server clusters. It's very expensive. It's hard. There's a lot of administration. It's hard. I've been there in those environments, and it's not easy. And those systems honestly still struggle. I know some people can do it, but for 90% of the businesses and data teams out there, it's just not a scalable way to do it. The data was growing too fast, and it's just hard to run queries even on a Postgres cluster on 300 terabytes of data. I'm sure there's people doing it, but it's just it's hard to do that. Not that many people were doing it or able to do that. And so things like Delta Lake came along, and I think they're groundbreaking, right? So like the in-between world was like all relational databases, and then people just started, things like Parquet files came along. People just started storing them in cloud buckets and S3, right? We're just going to forget the database. We're just going to store all this data. We've got too much of it. We're going to store it in S3 as just Parquet files. We try to apply some logic to it. I've been in those systems. I've been around them and worked in them back in the day, and they came with their own challenges, right? Sure, you got scale out of it, right? You could put Athena or Spark or other stuff on top of those files and start doing more analysis at scale, right? The scale, it solved the scale problem, but you lost all this sort of data warehouse classic relational database things like updates and merge statements and deletes and creating tables, right? Just the logical physical model changed when you're just writing files, and everything became harder, right? So you gained scale by moving to files stored on S3, but you lost a bunch of awesome stuff that came with relational databases, but they were failing because of size requirements, right? They were struggling to do these workloads in the hundreds of terabytes, even a couple terabytes, right? Postgres is going to start choking at that point. Enter Delta Lake. So keep that all in mind. So like, what is Delta Lake, a lakehouse? So Delta Lake, conceptually, how I explain it to someone is it's like 90% Postgres on files, on file storage, right? So instead of using a relational database, a technology like Delta Lake is using files in the background, right? It basically took the best of both worlds. It took this data lake of just files sitting around that could scale, it's better for scaling, right? And then you could partition them, those files, and it just helps scale out, being able to crunch sizes of data by putting Spark on top of it, right? But then we lost all that stuff from relational databases like update, delete, all that sort of like create table. This is the way that makes data modeling easy and applying data manipulations through that ANSI SQL type data manipulation. It's like Delta Lake is the combination of those. It's like taking the scale, putting it in here. Oh, we lost all this other stuff like create table, delete, update, merge. Oh, we have that too now. And we put them together and you have Delta Lake. I think it's a game changer. Delta Lakes, with good partition pruning and good practices, you can scale that thing up, man. It can petabytes, hundreds of terabytes. I personally use it to crunch hundreds of terabytes of data, and it feels as easy as Postgres, right? It doesn't feel hard. You're solving this super hard problem, right? And yet it feels easy. Now, Delta Lake it's a storage layer, right? It's not compute. So a lot of times it's paired with other technologies. Right now, Spark mostly. People are probably used to Delta Lake because of Databricks, its popularity in Spark. And while this is true, Delta Lake is open source, and there are not coming out a lot of standalone Delta readers like Rust and Python where you can just read. You don't need Spark to do that. You can. And it's just exciting time. I think people need to really understand conceptually the difference between like Postgres and Delta Lake and when you should choose one over the other, right? When you're going for scale, but yet you need analytical workloads to be processed at scale, that's when you pick Delta Lake. If you've got response time requirements and not big data, that's when you choose Postgres, although of course there's crossover from both ways, right? Like Postgres, set up correctly can handle big data, and you know what? Delta Lake can actually run, queries on small data, and it's fine. There is crossover. But I think it's important to understand what Delta Lake is. So at a high level, what do you need to know about Delta Lake? It's a storage layer. It's open source. It can sit on top of anything, anywhere you can store files on your local hard drive to a cloud storage system, right? How does it work? It basically writes Parquet files in the background. It has a transaction log. There's lots of other content about the internals of that you can go read and watch. So it basically keeps track of the correct state of things, and it gives you things like update statements. You can delete, you can create tables, you can do merge statements. It just makes everything easier. A lot of people use it with Spark. It's probably the majority of the use case, but you don't necessarily have to. You can query Delta Lakes with just Python or Rust. Of course, there's things about manage, just like anything else with technology. It's, can shoot yourself in the foot. There's very important concepts when you're learning new tools like Delta Lake. Since it's files in the background, easily run into small file problems that have been very common for years. But there's things in place. You have to optimize as a command, SQL command you run against your Delta table that will compact a bunch of smaller files into larger files, right? So you don't have thousands of small files to scan through at scale, right? Because that slows things down. Has a lot of cool features like Z orders, right? It's not classic indexes like people think about, but for high cardinality columns, you're scanning a whole set of files looking for a particular needle in a haystack. They have things like Z order to help with that sort of thing. There's vacuum, clean up deleted files. So there's a lot of similar concepts to people are used to with relational databases, but a big one is partitions, right? Partitions are incredibly important when you start dealing with file-based storage systems. How are you splitting up those files? If you have 300 terabytes of data and you partition by customer ID and you have 10 million customers, that's a bad idea because now you have way too many small files. It's very common to partition Delta Lakes by some sort of time series, right? Where you're spreading the data evenly across a bunch of files. So I would read into partitions if you haven't heard about them or used them. It's an important concept, and it's probably going to become even more important in the future. So that's just a little bit of a rant about Delta Lake. I feel like it is getting popular, more people are using it, but I think there's a lot of people who are not using that should be. Just dropping files, and still too many data engineers just throwing buckets of files into storage or somewhere, and it's just a nightmare. And people need to learn about Delta Lake. It's open source. You can use it with Databricks. You don't have to. It's an incredibly powerful way to crunch data at scale, to organize file systems of data. You can get rid of the management overhead of relational database, and that is a nightmare for anybody that's worked with relational databases for years. You know what headaches I'm talking about. It's not the silver bullet. It's not going to totally replace. It's not a replacement technology for relational databases. It's an addition. It's the next evolution of file storage for data engineering. So yeah, go read about Delta Lake and use it.